In this section, we're going to talk about lines, straight lines in particular, and these are a fundamental building block of lots of concepts that we're going to cover in calculus. So we'll take a little bit of time reviewing. Everyone should be familiar with a line. But first off, let's kind of see what the key points are. So we've got our regular coordinate system. A line is a relation between two variables, x and y, and it's as you would guess, a straight line. So what are some key components? Well, every line is gonna, we have some kind of anchor on it. Say that we know this is the point. I'm gonna be arbitrary and call it x1, y1. So it's some arbitrary point. We can look at that. We can also look at, we'll see in one form, where it crosses the axis, and we'll call that the y-axis. We'll call that b. And then we'll need some other arbitrary point on the line. So we'll call that x, y. And in your algebra career, you've come across many different forms of how to describe this line that we've drawn here. So first one I'm sure you've run into would be called the point slope form, in which it's the relation between x, y, and another. So this is an unknown point, and this is some known point. So that's why we have the subscript. It's given to you by a problem. You know some location on the line. You know that the point x1, y1 is on the line. And in the point slope form, you need to also know the slope of the line. So the slope of the line is simply the change in, if I'm starting at this point here, how far up do I have to go in the y direction, and how far up do I go in the x direction. So we'll call this distance delta y, and this distance delta x. And this is going to be our slope, and slope is simply the ratio. It's the change in y over the change in x. So our point slope equation uses that idea, and so we know that the equation will be y minus, so this is the unknown point, over y1 is equal to m times x minus x1. Now, why should this equation be related to this line? Again, this should be a familiar equation you found in algebra. Hopefully it was explained to you before, but it may have been a while. Well, let's come back and look at our definition here. M is the slope. It is the change in y over change in x. Well, what is the change in y? Well, if we have the point here, y1, I need to go up to y, so then the change in y is going to be y minus y1 divided by the change in x, which is how far are we moving in the x direction. So that's x minus x1. So we see we have a relationship here that the slope, m, is equal to y minus y1 over x minus x1, the change in y over the change in x. And this ratio, change in y over change in x, is the ratio of interest in all of calculus. This is what motivates at least differential calculus, this change in y over change in x. So look at this equation, change in y over change in x. You're going to see it in so many contexts, and so many problems just boil down to what is the ratio of the change in y, change in x. So we've got slope is equal to this. Well, if I multiply by the denominator here, so wipe out the denominator, I'll get y minus y1 equals m times x1. So that's where the point slope form comes from. Now, we could solve for all of this, bringing the y1 over, multiplying through, and collecting the like term, and what we'll have is what happens when x is 0. Right? Because this point here, if the y-coordinate is b, we can let x be 0 here, and bring this all over, and I'll end up with what we know of as the slope-intercept form. So let me open that. And so now the equation for slope-intercept form is y equals mx plus b. Okay, so all we've done is we've let x1 be 0, and then we get an mx, and then the y1 that corresponds to when x is 0 is exactly b. So it would come over, and you get the slope-intercept form. And for another version, maybe less observed, is we could just write it as ax plus by plus c is 0. There's another equation of a line, and I'd recommend taking a little bit of algebra, or on your own, work the algebra out. But I can convert this equation easily into something that looks like this. How would I do it? Well, I would divide by the coefficient of y. A divided by b becomes my slope. So I get that in this case, m is equal to a divided by b. So the coefficient in front of x is our change in y, while the coefficient in front of y is our change in x. It's a little bit confusing, but the algebra works out, and I could bring this all over and set it equal to, actually it's a negative. Be careful with signs. It's a negative, because if I have to bring this over, I get a negative sign, and I see I've got the slope-intercept form. Now this is all great as long as the line has a slope, but what if it's a vertical line? So if it's a vertical line, then the change in x is 0, in which case I would be dividing by 0. So obviously a vertical line doesn't have a slope in this case. In that situation, then we just say, well, x is equal to some constant. And so then that graph is a vertical line. Maybe this is the point A, and then the graph is just a vertical line that goes through the point A.